Today our topic is finding midpoint and distance. So our essential question, how can I find the midpoint and distance of a line segment? Midpoint is the point on a line segment that divides the segment into two congruent segments. So if we look at our example, M is the midpoint. It's dividing it into two congruent segments right here. So we would say PM is congruent to MQ. Or we can also say that PM is equal to, and then this should say MQ. Either the measurements are equal or the segments are congruent. Segment bisector is a point, ray, line segment, or plane that intersects the segment at its midpoint. A bisector is something that cuts another object in half. Alright, so if we look at our example, PR would be the bisector. Because, as we can see, it's going through the midpoint S because we have 12 and 12 on either side, which means S is your midpoint. Example, point S is the midpoint of RT, so this is cutting it in half. Find the length of RS, then find the length of RT. So find the length of RS, this piece, then find the length of the whole thing, the whole line. So we know that 5x minus 2 is going to be equal to 3x plus 8 because the segments are congruent, which means their measures are equal. Set them equal, we get an equation to solve. Solve the equation. Get your variable to one side. Get the other numbers to the other side. We get 2x equals 10. Undo division. Undo multiplication with division. We get x equals 5. Now, all we know is that x equals 5, but we want to know what's RS, which means we need to evaluate 5x minus 2 when x equals 5. So plug that 5 in for x. And we get 25 minus 2, which is equal to 23. So we can say that RS is equal to 23. The next piece is to find out the total line segment. What we know is that 5x minus 2 is equal to 3x plus 8. So 5x minus 2 is 23. 3x plus 8 is going to be 23. Add the two together to get the length of the whole segment, and we get 46. So RT is equal to 46. Midpoint formula. If A, x1, y1, and B, x2, y2 are points in the coordinate plane, then the midpoint M of AB has coordinates x1 plus x2 divided by 2 and y1 plus y2 divided by 2. We're finding the average of the two coordinate points, which makes sense because the average is right in the middle. So example, the endpoints of RS are R1, negative 3. So if we plot that point on our graph, and S, 4, 2, find the coordinates of the midpoint. So if we look on the graph, we get a visual of where we think our midpoint should be, somewhere right in the middle there. And then we can use our equation to solve. So we have points 1, negative 3, which would be x1, y1. 4, 2, which would be x2, y2. Plug it into our midpoint equation. x1, 1, plus x2, 4 over 2. And then y1, negative 3, plus y2 over 2. Solve that. We have 1 plus 4 is 5. So we have 5 halves. And negative 3 plus 2 is negative 1. So our coordinate point would be 5 halves, negative 1 half. So if we plot that on our coordinate plane, right there, coordinate point M, that looks like it is right in the middle. So that would be our midpoint. Next section is measure and classify angles. Essential question, how can I measure and classify angles? Key terms. Angle. Two rays with the same endpoint. If you look, we have endpoint here, one ray there, second ray there. Rays are the side of the angle, and the endpoint is the vertex of the angle. So right there, vertex, that's that point where the two rays meet. To name an angle, the vertex always go in the middle. We use a little angle marker. We can put 1 point on the side ray. The vertex goes in the middle, and then the other point on the side ray. You can also flip-flop the outside and the two outside letters, so it could be angle C, B, A. You can also just name it by its vertex, so it could just be angle B. As long as there's just one angle, that could be angle B. Classifying angles. An angle which measures 0 to 90 degrees would be acute. It cannot equal 90, so cannot equal 90. Angle that measures 90 to 180, it cannot equal 90, and it cannot equal 180, but it can be in between those would be obtuse. A 180 degree angle is a straight angle. And a 90 degree angle is a right angle. Angle addition postulate. If Z is in the interior of angle ABC, then the measure of angle ABC equals the sum of the measures of angle ABZ and ZBC. So if we look at the image, it makes more sense. If Z is in the middle of angle ABC, it is. Then the measure of this big angle right here is the sum of the two angles on the inside. So it would be the sum of this angle and the sum of this angle. It makes sense logically. The two angles on the inside make up the whole angle. So given that angle ABC is a straight angle, which means it measures 180 degrees, find the measure of angle ABD and the measure of angle DBC. So the measure of angle ABD, ABD, and the measure of angle DBC, so DBC, which make up the straight angle ABC. So we know that this angle plus this angle is going to equal 180. So if we set up an equation to solve, 5x plus 10, add it to 2x minus 5 is going to equal 180. Solve this equation, add your like terms, down to a two-step equation, undo plus 5 with a minus 5, we get 7x equals 175. Divide both sides by 7, and we get x equals 25. However, that's just x. If we just have x is equal to 25, did we answer the question? No, we want the measures of both the angles. So we have to plug x equals, what was it, x equals 25 in for both angles. If we plug 25 in for 5x plus 10, 25 times 5 is 125, plus 10 is 135. So that would be the measure of angle ABD. Then on this side, if we plug 25 in for our equation, 2x minus 5, 2 times 25 is 50, minus 5 is 45 degrees. So that would be the measure of angle DBC. Last piece, congruent angles are just two angles that have the same measure. So as long as they have the same measure, they are equal and they are also congruent. The same arc is used to show that angles are congruent. So here I marked these angles as congruent by using this arc. You will sometimes also see like a double arc that can be shown to mark congruent angles. And then angle bisector. That word bisector, remember, means cut in half. So is a ray that divides an angle into two angles that are congruent. So it's making these two angles congruent. That's all the notes I have for you today. Thank you for watching this video, and please subscribe to my YouTube channel.